All right, hey you guys, this is Miss Eccles. We are in predicting results of rigid transformations tutorial. I'm on slide number 6. So this is the last lesson for unit 1. So we are going to talk about transformations and what's going on with them. We're going to do a lot of GeoGebra activities in this one. It's going to be a long one, you guys. Page 6 has a lot of information. It's like 3 parts. Several things for each part. So I guess we're just going to get into it and email me if you have any questions. All right, so click on single transformation, see what's going on. Okay, so it looks like I got some kind of, looks like trapezoid. I'm not sure if it is one. To be a trapezoid, BC and AD would have to be parallel to each other. It looks like AB and CD, of course, are not. That's why I say it's a trapezoid, or it could be. I had to look at their slopes. But it looks like this one's a slope's a -1, AD, it looks like a slope of -1 also. So to me, it looks like a trapezoid. It looks like I got some kind of point here. Could be a point of reflection. Could be a point of rotation. Yeah, not sure yet. Let's see what's going on. All right. Okay, so question 1. First, you will examine how reflections affect the orientation and location of quadrilateral ABCD on the coordinate plane. Predict what will happen to the coordinates of point xy as the point reflects across a line to produce x prime, y prime. Choose the x-axis, y-axis, y equals x and y equals negative x, the lines of reflections. And express your answers in terms of x and y. Be sure to watch your signs. Okay, so basically this is asking for the rules. I call them cheat codes. If you are ever playing a video game and you get stuck in something, you can always go to the internet and find a cheat code to give you more energy or to give you more lives or to get around whatever you need to get around. So this is what a cheat code is. It was back in the last, no, it wasn't the last lesson. It was the lesson on transformations. It was one of the slides that we went over. So let me just give you the rules. Again, these are cheat codes. So for the x-axis, if you reflect across the x-axis, basically it's your y that changes signs. The x will stay whatever it is. If it's a 1, it's going to stay a 1. If it's a 2, it's going to stay a 2. If it's a -5, it's going to stay a -5. But the y is going to change. So that's going to become whatever the opposite sign is. So if y was a 5, now it's going to be a -5. If it's a 2, it's going to be a -2. Now, opposite for the y-axis. If you're flipping across a y-axis, like a reflection, the x is going to be the one that changes. So the x is going to change signs, but the y will stay the same. Y equals x. I like this one. It's super easy. Whatever x and y are, you switch their positions. So if it's x, y, now it's becoming yx. They just switch places. And y equals -x. That line, not only do they switch, but they also change signs. So you're going to switch them, whoop, and now it's going to be a -y and a -x. Again, those are just cheat codes. They're not really how you would do it, like physically get in there and do it. Those are just the codes for how you would take care of the ordered pairs. All right. See what's going on in part B. It says, enter the numerical coordinates of the vertices for the quadrilateral ABCD, and the table point A has been done for you. Then predict the numerical coordinates of the vertices for quad A prime, B prime, D prime. Okay, so basically it's asking me to show you, using the cheat codes up here, what the answers are going to be for an example. All right, so let me come back and get B, C, and D, what those coordinates are. And again, nice thing about GeoGebra, it does give it to you over here. So we got A is -3, -2, and that was been done for us. All right, B is -2, -1. C is -1, -2. And D is -1, -4. Okay, so they're asking for the cheat code. Now, x-axis, remember what I said just a second ago. The x value stays the same. The y is the one that changes signs. So what I'm saying is this -3 is going to stay a -3. This -2 is now going to become a +2. For B, -2 stays a -2, but the -1 is going to change and become a +1. Again, I'm just using a cheat code here, you guys. I'm not doing it visually. I'm not going into, your GeoGebra and figuring it out. The cheat code is that the X stays the same, the Y changes signs. So this X stays the same, the Y changes signs. So there's your cheat code for the X-axis. All right, now the Y-axis. Okay, you're going to go back to your original figure every single time, the regular A, B, C, D. Again, that's your pre-image. We are going to go back. Now, the Y-axis cheat code is the X changes signs, the Y stays the same. So every first number is going to change signs. The second number is going to stay the same. So again, I'm going back to my original. So I'm changing this -3 to a +3. The Y is going to stay the same. So again, Y-axis, X changes signs. So this -2 is going to become a +2. The -1 is going to stay the same. -1 becomes a +1. This -2 stays the same. -1 becomes a +1. This -4 stays the same. So one more time, Y-axis, that first number changed. Every X value and every Y value stayed the same. All right, Y equals X. The cheat code is you're going to switch their places. Don't change any signs because there's no negatives here. You just take your original A, B, C, and D, X and Y value, and switch their places. So this -3, -2 is going to switch. Now it's going to be -2, -3. This -2, -1 is going to switch. Now it's going to be -1, -2. -1, -2 is going to switch. Now it's going to be -2, -1. I'm not changing signs. I'm just switching their places. -1, -4 is going to become a -4, -1. So for Y equals X, the cheat code is just switch them. That's it. All right, Y is -X. Not only do you switch them, but you're going to change the signs of both. So I'm going to switch this -2 with this -3, but the change is going to come in the signs. So now it's going to be a +2, +3. So I'm going to take this -2, -1, I'm going to switch them and also change their signs. So it's going to be a +1, +2. -1, -2 switches. Now it's going to be a +2, +1. All right, I'm going to switch this -1 and -4, but now they're going to change signs. +4, +1. And that is it. I'm going to hit submit. So there's a couple of examples, 4 of them actually, for X-axis, Y-axis, Y equals X, Y equals -X. You're probably going to want to write these cheat code down somewhere, maybe in your notes you're taking, because it's in the mastery test. It's also in the post-test that's coming up after this lesson. So you definitely want to have these cheat codes to help you on your test and your practice problems, you guys. I'm letting you use your notes. You're taking these at home. Hey, use your notes. That's what they're there for. All right, part C. All right, now check your predictions in GeoGebra. Draw the lines of reflection of Y equals X and Y equals -X, then reflect the quad ABCD around the X-axis, Y-axis, Y equals X, Y equals -X. So for you visual people, they want us to visually do this. Okay, so let's see here. All right, so they want it. What was the X-axis first? Yeah, I got to reflect across the X-axis. Okay, so let's see. I know my transformation is this one. It's going to be reflect across a line. So I'm going to click on reflect across a line. I'm going to select the object first, and this is my X-axis. So I'm going to click on the X-axis, and let me move it so you guys can see. There's my figure. So I'm looking for A prime, B prime, C prime, D prime. So here are my coordinates. A prime is -3, 2. B prime is -2, 1. C prime is -1, 2. And D prime is -1, 4. So it reflected across the X-axis. And Yeah, they're the exact same of what I got for my prediction using my cheat code. So I'm just going to put in what I had up here. I'm going to have -3, 2, -2, 1, -1, 2, and -1, 4. So my predictions were correct. Cheat code works, you guys. So use your cheat code. Plug these in. Again, if you're a visual person, there's nothing wrong with using GeoGebra. If you are someone who's been attending my classes in person, then you've heard me say, keep your GeoGebra open while you're doing this, doing your mastery test and doing your post test. If you're a visual person and you need to see it flipped over that x-axis, leave your GeoGebra open when you do this stuff, okay? All right, so next one is y-axis. So I'm going to take my original quad. I'm going to reflect it across this y-axis right there. All right, so I'm going to come to reflection across a line. Click on my original pre-imaged figure, the y-axis, and there is my new figure. Now you notice this is all labeled 1s. So when I come over here and look at my order of pairs, I'm looking for the ones that have A1, B1, C1, and D1. So it looks like I got 3, -2 for A1. B1 is 2, -1. C1 is 1, -2. And D1 is 1, -4. So they are the exact predictions that I had using my cheat codes. So if you use cheat codes, great, good for you. If you want to come over here and use GeoGebra, great, good for you. You're going to get the same answers regardless, you guys. Doesn't matter which way you do it. Let me pull in these ordered pairs for you guys. So that was 1, -2, and then 1, -4. Okay, so I got to reflect across the line y equals x. Well, my figure doesn't even have the line y equals x there. So what I'm going to do is I'm going to undo these. Because I want you guys to be able to see what's going on. Well, first thing I got to do is I got to create the line y equals x in order to flip it across. So I'm going to need a line. Well, y equals x, if you remember your stuff from Algebra 1, is the one that cuts the quadrant 1 and quadrant 3 in half. So if you're looking at like y equals mx plus b, is the one that has a slope of 1 every single time. So that's your y equals x. Now our cheat code is to switch their positions. Whoop! This little quad right here is going to flip across this line. So a lot like if you've ever made pancakes, it's literally going to pick up and flip over that line and practically land on top of itself, at least partially. So I'm going to reflect across the line. I'm going to select my quad, select this line I made, and you can see how it kind of reflects over itself. So it partially lands back on top of itself. Either way, I've got my coordinates up here, and these are all labeled prime. So there's A prime, B prime, C prime, and D prime. So A prime is -2, -3. And as you can see, all they do is switch places if you're using your cheat code. Cheat codes are faster, you guys. If you've been in my class, then I have talked about the ACT a lot with you guys. And of course, transformations are on the ACT. And you don't have the luxury of having GeoGebra on your ACT. What you do have the luxury of having are your cheat codes. And you know, you want to have these done in fast as possible on your ACT. All right, so the line y equals -x, it's just the opposite. If this is y equals +x, y equals -x is the one that splits the quadrant 2 and quadrant 4. So I'm going to get rid of this, so if you're a visual person, you don't get confused about what's going on. So I got to draw the line y equals -x. And again, that's the one that splits quadrant 2 and 4. So it's going to look like a negative sloped line. And I want to reflect it, my quad across this line. Oh, I'm sorry about that. Reflect it across this line. So it's going to sit over here. So I'm going to go to reflect across the line, select my figure, select y equals -x, and you can see it flips across this line. So if you're a very visual person, that's a nice representation of it. So I'm looking for A prime, B prime, C prime, D prime. So A prime is 2, 3. So again, you guys, the cheat codes work. Not only do you switch their places, but you change the signs of both. One more time, this is great for the ACT, and that you can get your answer very, very quickly. So if you're looking for a high ACT composite score or even a math sub-score, you want to know these little cheats so they kind of help you guys. So as you see, I got it submitted, and of course my predictions and the real visual representation are the same. All right, so there's what it looks like if I hadn't erased everything. It looks a lot like a rotation if you haven't really noticed that. That's because a series of reflections ends up being a rotation. And we are definitely going to talk about that here in a few minutes. Part D, compare your answers in Part B and C. Did your predictions for the coordinates of the reflected images match the actual results? Well, yes, they do. Because I'm a very visual person, I teach visually for my visual people using GeoGebra, but you know what? You've got to have these little cheat codes for the ACT. Yes, they were the same. All right, I followed my rules and they came out to be the same. All right, so there's question 1, done. All right, so it looks like we're on to question number 2. Okay, so these are the cheat codes for your rotations. Now, if you've been in class, we've done this before. They're in one of your slides for your rotations going back to your transformations page. That's the one that we had to split into 2 parts if you were on campus because we just couldn't get it all taught in one day. All right, so I'm going to hit single transformations to open up my GeoGebra. Okay, looks like I got the same figure, but I guarantee you this time I'm not going to do a reflection. I'm going to do a rotation. All right, so these are my rotation cheat codes. You might want to get a pen and paper or a pencil paper, write these down somewhere, you guys. You're going to see them on your mastery test and also your post test. All right, so I want you to see this first off. This CCW means counterclockwise. CCW is counterclockwise. On the ACT, if they do not specify which direction you go, because you've got clockwise and counterclockwise, if they don't specify, it is counterclockwise, which is to the left. I know that probably goes against everything that you can think of because when you read a clock, you read it clockwise. Everything goes to the right, but ACT doesn't do that, you guys. So you need to know counterclockwise for sure. So these are the rules for counterclockwise, and again, ACT, if they don't specify, they mean to the left, counterclockwise. All right, so your rules for 90 degrees counterclockwise. All right, not only do they switch places, but the only thing that changes is your Y. So we're going to put negative Y first, and then X goes in the back. X does not change signs. 180 degrees is the same thing as a reflection across the origin. We just saw that. All they do is change signs. X stays where it is, but it becomes a negative X. Y stays where it is, but it becomes a negative Y. So a rotation 180 degrees and a reflection across the origin are the same thing. I'm going to say it one more time. 180 degree rotation and a reflection across the origin are the same cheat code. All right, that's something to remember, you guys. All right, looking at 270 counterclockwise. All right, so they're going to switch places, but the Y is going to stay whatever sign it was. The X is going to change signs. 360 degrees. Well, all you're doing is landing back on top of itself. So X is going to stay an X. Y is going to stay a Y. Like I said, you're going to want to write down these cheat codes, you guys. Write them down. There's no way you're going to remember these for your mastery test or your post test. There's just no way you can remember all this stuff this soon. As we get through and going and practicing, when you see this over and over and over again, hopefully it gets stuck in your head for your ACT. Because they're not on the ACT, this is something you're going to have to remember for the ACT. So those are your cheat codes for rotations counterclockwise. Again, that's CCW. That is to the left. Okay, looks like we got an example coming up. If it's anything like our reflections, part B is going to be using your cheat codes. Part C is going to be using your GeoGebra. So this is the cheat codes, you guys. This is for the cheat codes. Part C is for you visual people. All right, so I need to get my coordinates for B, C, and D. And I would imagine they're probably the same as what they were earlier. So B is -2, -1. C is -1, -2. And D is -1, -4. Okay, so those are my originals. Again, what we call that a pre-image. ACT calls it a pre-image. So you're aware that's my original figure. Okay, let me scroll back up here so you can see what my cheat code is. For a 90-degree counterclockwise, I'm going to switch their positions, but whatever the Y value is changes signs. So this -2 is going to become a +2. This -1 is going to become a +1. -2 becomes +2. -4 becomes +4, and it sits in the front. So it's going to be +2, keep the -3. It's going to be +1, keep the -2. This is going to be a +2, keep the -1. And this is going to be a +4, keep the -1. So that's your cheat code for the 90 degrees counterclockwise. All right, 180 degrees. Whether it's counterclockwise or clockwise, you guys, that's the same thing as a reflection across the origin. All you do is change the signs of both so that -3 and -2, they're going to stay where they are, but they change signs. So they're both now going to be positive. Both of these are now going to be positive. Stay where they are, change their signs. Stay where they are, change their signs. Stay where they are, change their signs. All right, 270 counterclockwise. The rule is you switch them, but the X is the one that changes signs. So this -3, that's the X value, it's going to be a positive. -2 changes to positive. -1 changes to positive. -1 changes to positive. So they're going to switch places. The X value changes signs, so it's going to be -2, change to +3. This is going to be -1, change to +2. This is going to be a -2, change to a +1. This is going to be a -4, change to a +1. Keep these cheat codes on, you guys. It's going to be hard to remember this, your first mastery test. All right, 360 degrees, all they do is stay the same, so nothing changes here. -3, -2. Whoops. Keep it the same. Remember, I'm going back to my original, so -2, -1. -1, -2. -1, -4. Nothing changes for a 360. Bam, there you go. Look at that. My cheat codes. Rock on. All right, but not all of us are cheat code people. Some of you guys are visual people. You just see it to get it. We are going to rotate 90 degrees, 180 degrees, 270, and 360 counterclockwise. And again, that's what ACT does. But you're going to find they're going to be the same, you guys. Cheat codes and visually, they stay the same. All right, looks like they gave us all the order pairs. That's super nice. Thank you. Excuse me. Sorry. Thank you for that. All right, so let's see. We're going to rotate 90 degrees counterclockwise. So rotation around a point. So we're going to click on rotation around a point. We're going to click on our figure and the point of rotation. And it pulls up this box right here where our first one was 90 degrees counterclockwise. So I changed this to a 90 kept it counterclockwise, and hit OK. So as you can see, it just rotated around 90 degrees counterclockwise. So I'm looking for A prime, B prime, C prime, D prime. Over here, look at, there it is. A prime, B prime, C prime, D prime. And 2, -3 is our A prime. 2, -3, looky there. There it is, the same. So for you visual people, our cheat codes, they work. So I'm just putting in the results from my visual rotation, which happens to be the same as my cheat codes. All right, 180 degrees, counterclockwise. All right, visual people, click on your object, click on the point, change this to 180 degrees, keep it counterclockwise. Hit OK, and there it is. So again, you can see a reflection across the origin and a rotation of 180 degrees, whether it's counterclockwise or clockwise, ends up being the same stuff. So I'm looking for A1, B1, C1, D1. There it is. 3, 2 is A1. And 3, 2, there it is, A1. So again, just goes to prove if you're using cheat codes or if you're visually using GeoGebra, they do come out to be the same. All right, 270, counterclockwise. All right, visual people, click your original, click your point, change it to 270, keep it counterclockwise, hit OK, and then you can see it rotates around to 270. So there's 90, 180, 270. So when I hit 360, it's going to land right back on top of itself. But these are my order pairs for 270. I'm looking for D1, not D1, D2, C2, B2, and A2. So I'm looking for the ones that have twos. So I got a -2, 3, -1, 4, so forth and so on. So as you can see, they are the exact same. Whoa, my bad. Put that as an open parenthesis. -2, 3, -1, 2, -2, 1, and -4, 1. All right, last one is 360, my visual people. Pick on the object. Click on the point. Change this to 360. Keep it counterclockwise. Hit OK. Well, oh, look at this. So we got an A and an A3. So this was primed. A1 prime, B2 prime. This is going to be A3 prime. So you see it just lands right back on top of itself. So I like this. If you're visual looking at this, your original A and then your A3 are going to be the exact same. B, -2, -1. B3, -2, -1. They're going to be the exact same. Just goes to prove, visual people, yeah, there you go. Going to be the same. So nothing's going to change. So it's -2, -1, -1, -2, and -1, -4. Make that a little bit bigger so you guys can see. There's your answer. So cheat code or visual, it doesn't matter on the mastery or post test, but ACT, probably going to want to know that cheat code. Yes, they were the same. All right. Listen, if you got any questions as we go, I mean, don't hesitate to email me or send me a message in Clever. That's probably the best way to get a hold of me. All right. Looks like we're doing what? Transform. What's going on here? Predict the results of what happened of X, Y as the point translates. Okay, so we're going to translate some stuff. That just means we're shifting. Up, down, left, right. We're going to be shifting something going on here. So let me click on my GeoGebra. We have the same darn figure again. Let me move and see. Yeah, we do. All right, so we got the same figure again. We got our what looks like a trapezoid. We got a point of reflection and rotation, but this time it looks like we're going to be doing some translating. All right, so let's see what it says. Assume that the point translates A units to the left or right. All right, so if we're going left or right, it's going to be A. B if it's up or down. So if we're going up and down, it's going to be B. Express your answers in terms of X, Y, A, and B. Be sure to watch your signs. Okay. All right, so if I'm going up means B. So let's see. X will stay the same. But if I'm going up, it's going to be whatever your value is plus B. Because I'm going up. So I'm using the B for up. Down would be, okay, well, X stays the same. But this time I'm going to subtract the B. Because down, you're subtracting. All right, so left and right, that's when my X is going to change. So Y will stay the same on both of those. But if I'm going right, I'm adding, well, they want me to use A. I'm adding an A to your value of X. And if I'm going left, I'm subtracting A away from X. All right, so there's your cheat codes for translations. Submit that. Okay, cool. Cheat codes for translations, you guys. Okay, so here's our example. I bet they want us to use our cheat codes here. Part C probably want us to. Yeah, they actually want us to use GeoGebra to do it. Okay. Told you guys this is a long one. All right, so let's see. I need to go back and get B, C, and D. All right, so let's see. B was -2, -1. All right, C was -1, -2. I feel like I should know these by now. I should have it memorized, I would think. And D is -1, -4. Okay, I am going 7 units up. Now, up is when you add that number 7 to the Y value. So X is going to stay -3. Now I'm going to add -2 plus 7. So grab your calculator if you need it, but -2 plus 7 is a 5. So -2 is going to stay the same. I'm going to take this -1. I'm going to add 7. So -1 plus 7, that's a 6. So -1 is going to stay the same. I'm going to add -2 and 7. So -2 plus 7, that's going to be a 5. -1 stays the same. All right, I'm adding -4 plus 7. -4 plus 7 is a 3. So just using a cheat code, you guys, you're going to add whatever the number is to your Y value when you go up. Well, this time we're going 1 down. So my X is going to stay the same. I'm going to subtract 1 from whatever the Y is. So keep the X the same. So it's a -2. -2 minus 1 is a -3. Keep the -2. -1 minus 1 is a -2. Listen, if I'm going too fast and you're using a calculator, you can always pause this and check it out. Make sure you're doing it right. But I don't need a calculator, you guys. You should be able to add and subtract numbers. -1, sorry, my bad. -2 minus 1, that's a -3. Keep my -1. -4 minus 1, that's a -5. All right, now we're going to go right. Right means the second number stays the same, but you're going to add whatever they tell you to the X value. So for every X, I'm adding 4. So I'm going to add 4 to that -3. So -3 plus 4 is 1. I'm going to keep the -2. All right, so -2 plus 4 is 2. We're going to keep the -1. -1 plus 4 is 3. We're going to keep the -2. And last but not least, -1 plus 4 is 3. Keep the -4. All right, so this time we're going to go left, you guys. We are subtracting whatever the value is away from the X value. So in other words, we're going to take -3. We're going to subtract 3. So, well, -3 minus 3 is a -6. Keep the -2. -2 minus 3 is a -5. Keep the -1. All right, -1 minus 3. That's a -4. Keep the -2. Last one, -1 minus 3. That's going to be a -4, and you're going to keep the -4. So there's your cheat codes, everybody. Cheat codes for translating. Translating is shifting an object. And there are your answers to verify. Part C, looks like we're going to be doing this on GeoGebra. All right, so I need 7 units up. All right, so let's see. Let's see what translate is. Translate by vector is all they give us. So I bet I'm going to have to draw a vector. A vector is actually what airline pilots use to tell their plane where to go. If you didn't know, planes can actually fly themselves. It's just all computerized. You kind of tell it in the direction you want to go and the magnitude to get there. So we're going to be using translate by vector. And I'm going to go 7 up. So I'm going to click, I don't know if I click A. 1, 2, 3, 4, 5. Oh, I got to move this so I can see it. So at A, 1, 2, 3, 4, 5, 6, 7. So I got to go all the way up to here. So translate by vector. Up to 7. Don't you love technical difficulties? Oh, okay, here we go. Up to 7. All right, there we go. You gave it to me. I need the whole object. Something's going on here, you guys. Let me see what's going on here. All right, so I'm going to translate by vector. Select the object to translate. Oh, my bad. Undo. Sorry about that. Translate to vector. All right, translate. So select the object. I want to translate this whole object. And I need it to go up 7. It's not working. Let's click on a point. Oh, there we go. There we go. Sorry about that. I love technical difficulties, don't you? Okay. So I got it translated up, so I'm looking for my primes over here. So A prime, shoot, I didn't have it directly on 7. All right, that's the bad news. Let's see if I can scroll this up to make it better. Okay, so I didn't actually get there. I don't know if I can move it or not. There we go. Now it's on the 7. All right, much better. So we got -3, 7, -2, 8, -1, 7. Oh, I moved it more than 7. Whoa, major technical difficulties. Let's go back. I moved it more than 7. All right, let's get back to my original. Okay, I needed 7 from point A, not from the x-axis, so I do apologize. Oh, man, I can't get it all on here. That's the problem. All right, so let's see. It's 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7. Now maybe I can get it. Let's try B. B might be easier. All right, so translate by vector. I'm going to select the object. I can't get to it. This is frustrating. My screen's not big enough. All right, translate by vector. Select the object. There we go. So I'm going to go up 7 units. Boom. All right, now let's see if I got it. All right, there we go. -3, 5. -2, 6. -1, -5. There we go. My goodness. That was an ordeal. I apologize, you guys. Technical difficulties. My screen just wasn't big enough to get it. And then I went up too far. And then my screen wasn't big enough to get it again. So go figure. All right. Hopefully 1 down will go easier because 1 shouldn't be incredibly difficult to do. 1 down. Let me move this so you guys can see it. 1 down. All right. So hopefully this will be easier. All right. Translate to vector. Click on my object. I want to go 1 down. There's my new object. Much easier. All right. So I'm looking for A1. So there it is. There's A1, B1, C1, and D1. You're going to notice they're all the same. Looking at -3, -3. Yep, boom, there it is. -3, -3. All right, that was -1, -5. Okay, 4 to the right. All right, so I'm going to select my original. Let's see if I can do C. 1, 2, 3, 4 to the right. All right, so I'm looking for A2, B2, C2, and D2. By the way, there's your vectors. If you're looking at them, we don't teach vectors too much anymore in geometry. It's more algebra 2. Looks like a matrix is what it actually, what it actually looks like. All right, so A2, there we go, 1, -2, 2, -1, so forth and so on. So 1, -2, that's the same right there. So cheat codes work. And for you visual people, you can see what's going on. 2, -1, 3, -2, and oops, 3, -4. All right, we're going to go 3 to the left. Original figure. I did not select that point. Get off of there. Original figure. Love technology. There we go. Original figure. Come on. Get off of there. Translate by vector. I'm not starting to select the point. There we go. Now I've done forgot what it was. Was it 3 to the left? I think it was 3 to the left. There it is. So 3 to the left. 3 to the left. My goodness. So I'm looking for the 3s. All right, there it is. A3, -6, -2. So there's your -6, -2. -5, -1. -4, -2. And -4, -4. There you are, visual people. They end up being the same. So there's our up 7, down 1, right 4, left 3. Looks just like ours. If I were to scroll it out. There you go. All right, so compare. Yes, they are the same. Self-evaluation. Woo! Glad to be done with this one. You know what? I should really give my self-evaluation a 4. That technical issue, woo, that got me. I was getting just a little bit frustrated. All right, so that's it for page 6. I think there's another page I'll see you in just a minute, okay?